Unit 9 is going to be focusing on right triangles, which means they're a triangle that have a right angle in them. 9.1 is simplifying radicals. So before we get to the actual triangle pictures, this is a very important skill that you'll use a lot through geometry, use it in Algebra 2 and above, is simplifying these radicals. And so what is a radical? A radical is really just this square root symbol. Sometimes we have cube roots and fourth roots, and you could go on and on and on, but we're just going to focus on square roots. So a radical just means this symbol. It's used to denote square roots or nth roots. So any n, which could be 3 or 4 or 5, whatever. Okay, list perfect squares. When I say a perfect square, that's like literally if I gave you a bunch of little paper cutout squares and I said arrange them into a bigger square. You could put 4 squares together to make a square. That would be 2 by 2. You could add another one to the length and the width and have 3 by 3, and that would be 9 squares. And that's where these pictures on my back wall come from. They're perfect squares. But if I gave you a number like 12 and I said use your 12 squares to make a square, you couldn't do it. You could have 3 by 4 rectangle, but you couldn't make a square. Okay, so just because numbers are even does not mean they're a perfect square. So perfect squares in order. First one would be 1, because 1 times 1 makes 1. Then we talked about a 2 by 2 square, that's 4. 3 times 3, 9. So you're just taking each number times itself. Then it would be a 4 times 4, which would be 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. 12 times 12 is 144. And that should be high enough. Okay, so it says express in simplest radical form. So 128, if I tried to do that on my calculator, remembering that square root button is the second function of the x squared button, so you hit second, and then your x squared, which has a square root symbol above it, and I put in 128. I'm going to get a decimal because it's not a perfect square. But instead, what I need to do is pick a number from this list that I could split this up into, because I can square root these numbers. I want to start from the bigger end of my list. So I'm asking myself, can 128 divide by 144? No, of course not, because this is smaller, so no. 128 divided by 121? No. 100? No. 81? No, because 81 doubled would already be 162, so no. What about 64? So if I took 128 divided by 64, I do get 2. So what I want to do is break this up into a square root of 64 and a square root of 2. You could write it like that. You could write it all under the radical. All I'm doing is breaking up the number 128 into something else that multiplies to make 128, one of the numbers coming from my perfect square list. So I can go that or split them up. So then the square root of 64, or what number times itself is 64, would be 8. So I have 8 square root 2. That is simplified. If I wanted to check to see if they're the same, I already cleared it, but square root of 128 is that decimal. If I type in 8 square roots of 2, it's the same value. So I've not changed value, I've just changed how it looks. Okay, let's try number 2. 224, start from the top of your list. See what number would go into it evenly. 121, no. 100, no. 81, I wouldn't think so. Nope. If it's a decimal, then no. 64. Nope. Still decimal. 49. Nope. 36. 224. Nope. 224 divided by 25. No. You know 25s have to be something. Like a multiple, 25, 50, 75, 100. Okay, I found it. So it's 16 and 14. So I'm going to break this up. You're breaking up 224 into a 16 times 14, or 2 separate radicals like this. Square root of 16. What number times itself is 16? That would be a 4. Square root of 14. Now let's say you found that it divides by 4, which would have been a perfect square starting from the smallest end, which I say don't do that. What would happen is you would get, so you would put your 4 and then 56 and get 2 square root of 56. You're not done though, because 56 divides by the perfect square of 4 again. So you would have to go again and split 56 into a 4 and 14. Square root of 4 is a 2, multiply by the 2 that was out in front, so 2 times 2 would be 4, radical 14. This took 2 steps instead of this taking 1. So always start with your biggest squares going down so that you find the biggest one possible. It's kind of the same when you simplify fractions. You want to find the greatest common factor.